All right, in this lesson, we're going to focus on solving word problems with similar triangles. So we're going to solve word problems involving similar triangles. So for each problem, we're basically going to follow the same steps, which is, and this is pretty much all geometry problems. So step 1, we're going to create a diagram of the situation. So make a diagram. Step 2 is going to be to add labels with the information that they give me. So label the diagram. And then step 3, we'll figure out how to solve it. Obviously, that's kind of the hardest step. But once it's set up, usually it's easier to see how to solve the problem. Okay, so example 1. A 40-foot flagpole casts a 25-foot shadow. So we have a flagpole, we have its shadow, and then we want to find the shadow cast by a nearby building that's 200 feet tall. So let's just start drawing things and see if we can figure out how to turn this into some triangles. So a 40-foot flagpole. So let me draw. First, I'm going to draw the ground. Okay, so I have a flagpole that's 40 feet. Here's my flagpole. And then the shadow. So let me sketch out a shadow right here. And then I have a 200-foot building. And I want to know how long is that guy's shadow. So you're just trying to kind of draw the situation, and then we're going to label it and try to turn it into triangles. In this case, all our problems are going to be involving similar triangles. So we want to make triangles into our diagram. So the building is 40 feet. The flagpole is 40 feet tall, and the shadow is 25 feet tall. And I can see, right, I can see a nice little right triangle here if I just imagine connecting that line. So here's my right triangle. And then my building is 200 feet tall. And the thing I'm trying to find out is this shadow. And I have another little right triangle here. So what's important to know, even though this they don't look super similar in my diagram, is that shadow, the angle of the top of an object to the end of its shadow is the same at the same time. So like wherever the sun is in the sky over here, suns are not like squiggly. Wherever the sun in the sky is over here, it's going to make these two angles be the same. And so we have similar triangles here. Having the angles be the same makes the triangles similar. So now that we know the triangles are similar, we can solve this using proportions. So let me set up some space. So shadows make similar triangles. I guess that's maybe the key idea. So I can just solve this problem with a nice, easy ratio. I also know they both have a right angle. So that means their angles are all congruent. So let's figure out how to turn this into equivalent ratios and solve for x. So I'll just say the ratio of the top of my building to the shadow is 40 to 25. And then the ratio of my flagpole to its shadow is 40 to 25. And the ratio of my building to its shadow is 200 to x. So there's many different ways we could solve this proportion now that we've set it up. I'm going to solve it 2 different ways just so you can think about it 2 different ways. So the first way, I'm going to solve it the way we've been solving the equations in class. So I'll solve it by multiplying each proportion by the other side's denominator, or each fraction by the other side's denominator. So 40x over 25x equals 5,000. Let me make sure I'm doing this correctly. Is it 5,000 or 50,000? 25 times 200. 5,000, great. Over 25x. And so now I can just make my equation with my numerators. 40x equals 5,000. And so the height of the building's shadow will be 5,000 divided by 40. Great, so it's 125 feet long. So there's one more way that you can solve it. I just want to show you guys that way, just to see if it makes more sense to you. The other way to solve this proportion would be, well, there's actually multiple ways, but this is one way that makes sense to me. You could also think of it as scale factor and think about how much does it get enlarged by. So in other words, 40 times what gets me 500, gets me 200. And so I could do 200 divided by 40, and I'll see that my scale factor is 5. And so then I can just do 25 times 5. And so I also get x equals 125. So obviously both these methods get you the same answer. Solve the proportions, however, makes more sense to you. But the key step is setting up the diagram with the triangles. All right, we're going to do a couple more examples to just practice turning these word problems into triangles. Okay, a 10-foot ladder touches the side of a building at a point 8 feet above the ground. At what height would a 7-foot ladder touch the building if it makes the same angle with the ground as the longer ladder? Okay, so don't even start thinking about triangles yet. Just draw out what we have in the picture. So I have a building, I have a ground. Okay, and then I have a ladder. So first just make a picture of what's happening and then try to figure out, okay, where do the triangles come into this? So I have a 10-foot ladder, so this is the ladder. And it touches the building at a point 8 feet above the ground. So that's this height right here. Okay, so that's what I have. Now it's giving me a whole other ladder. So I'm going to just draw it as a separate picture and try to see what's happening here. So now it's saying, at what point would a 7-foot ladder touch the building if it makes the same angle? So same angle should be telling you, oh, we have similar triangles, right? Because the whole point of similar triangles is their angles are the same. So I'm going to make the same angle, but this time my ladder is only 7 feet tall. And what am I trying to find out? I am trying to find out at what height. So I'm trying to find out this height right here. So your first step is to just take some time and turn the word problem into a diagram, because at that point it's really easy to solve. So let's now write now we can easily see how to turn these triangles into some equivalent ratios. So what ratios could I set up? I could say the ratio of the height to the height of the building to the height of the ladder. So 8 to 10 on that first triangle is the same as x to 7 on the second triangle. There's other ways you could have set up the ratio, actually. Like you could have flipped it, right? It will get you the same. These don't matter, right? These would both work. It will get you the same solution when we solve it out for x, as long as you line everything up correctly. So let's solve this out. I'll just do it the way that we learned in class yesterday, but if you find other ways, then do it by other ways. So I will multiply both sides by the other side's denominator, and I will get 56 over 70 equals 10x over 70. So 56 equals 10x, so x equals 5.6. So it's good to just confirm, like obviously my answer should be smaller than 8 because this is a smaller triangle. So that makes sense. So x equals 5.6. Okay, we're going to do 2 more and then we'll practice this more in class. Okay, this one has a shadow again. It's almost the same as the first one, but there's a little trick with the units. So so a tree casts a shadow 40 feet long. So let me draw the ground. Let me draw a tree. Okay, and at the same time, a boy casts a shadow 8 feet long. Okay, so we have our shadows. And let's label everything. So the shadow of the tree is 40 feet. The shadow of the boy is 8 feet. And then here's the weird part. So here I have 5 feet 6 inches. So I can't just plug that into my picture because I need the units to be the same. So one key thing with all of these word problems is all units need to be the same to set up the fractions. If the units are different, then the ratios won't make sense. So how can I turn 5 feet 6 inches into feet only? Well, it's going to be 5 feet, and then there's 12 inches in a foot. And so now if I set it up as a fraction, well, 6/12 is 1/2. And so I can write this as 5.5 feet. And so now I can set up my ratios because I have all the same units. So whenever you see inches and feet, try to turn it into the same units to make sure that your ratios, that your proportions make sense when you solve them. So now I've got my triangles. I've got all my triangles labeled. And what am I trying to find? I'm trying to find the height of the tree. So that's X right here. So why don't you pause the video for a second and just make sure you can set up the proportion and solve it based on this diagram. Or at least set up the proportion and try to solve it. All right, so hopefully you tried this. Let's see, there's multiple ways to set up the proportion. So if yours isn't the same as mine, that's fine, as long as we ended up with the same answer. So I will say the ratio of the boy to his shadow, so the boy's height to his shadow, is the same as the ratio of the tree to its shadow. So this is another one you could solve. You could notice that 80, one way to solve it would be to notice that 8 times 5 gets you 40 and use that strategy. But I'll use our other method just because that's what we've been practicing. So let me multiply each fraction by each other's denominator. To get the same denominator, let's bust out a calculator here. I think it's 220. Let's see, 5.5 times 40. Okay, 220 over 320 equals 8x over 320. So happily, I have a nice easy equation now. 220 equals 8x. And so dividing by 8, I end up with 27.5. So it's always nice to just check and think, does my answer make sense? Well, my answer, at least I can see, makes sense because it's bigger, right? It should be a taller answer. The tree is taller than the boy because the tree's shadow is longer than the boy's shadow. All right, we're going to do one last problem, and then we'll practice more in class. And this one's a little bit different just to see some different types of problems. Okay, Dennis needs to fix a leaky roof on his house, but he does not own a ladder. He thinks that a 25-foot ladder will be enough to reach the roof, but he needs to be sure before he spends his money to buy one. He chooses a point P on the ground where he can visually align the roof of his car with the edge of the house roof. Help Dennis determine if a 25-foot ladder will be long enough for him to safely reach his roof. Oh God, there's a lot in that problem. So thankfully they're already giving us a diagram here. So I'm actually just going to solve this diagram and I'll worry about the 25-foot ladder later because what I need to know is this height, right? I just want to figure out how tall his house roof is based on what they've given me. So the tricky part here is that the two triangles are overlapping. So I want to redraw the triangles separately from each other because it's just easier for me to think about it that way. So I have this little triangle and this big triangle. And so in my little triangle, I have 8 feet 6 inches. Actually, let's convert these just to inches first. So 8 and then 6/12 is 8.5 feet. And then let's do this one. 4 foot 3 inches is 4 3/12. So if you do 3 divided by 12, that will get you 0.25. So this is 4.25. So that's my first triangle. Now my second triangle, you might say to yourself, oh, 23 goes down here. No, 23 does not go down there because 23 is just this distance. So to find this total distance, you have to add all of that together. So this side is going to be 23 plus 8.5. So what is that? 31.5. 23 plus 8.5. Okay, great. And then here's my x. So we had to do a lot of stuff just to make our diagram kind of usable to us. But now pause the video at this point and make sure you can solve for x using equivalent ratios. Okay, so just as usual, there's a lot of different ways to set it up, but I'm just going to do the height of the triangle to the base of the triangle. So 4.25 over 8.5, and then x over 31.5. So I'm going to just solve. So if you set up the ratio a different way, that's fine, as long as we end up with the same answer. So I'm going to solve my ratio. And so this one is a calculator for sure. 31.5 times 4.25. So 133.875. And then 0.5 times 31.5 is, okay. And then over here I have 8.5x over the same denominator. Okay, and so my equation is 8.5x equals 133.875. So x equals, so let's see, 4.25 times 31.5 divided by 8.5. Okay, so my x equals 15.75. Okay, but we still haven't actually answered the question. So let's look back at the problem and see what it's asking us. Help Dennis determine if a 25-foot ladder will be long enough to safely reach his roof. Well, I don't really know too much about ladders, but let's think about it. So the roof is 15.75. So if my ladder is 25 feet long, that feels like it should definitely be long enough, right? Because it's much higher than the top of my roof. So we'll say, yes, 25 feet seems safe. Okay, so hopefully some of those problems made sense. And there's a lot of pieces to this last one, but we'll practice a lot more in class till you're really good at solving these word problems.